Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 2 of 20. We often talk about data validation, but if you look closely at Pydantic, its primary goal is actually coercion. It guarantees the structure of your output, not your input. The anatomy of a base model is what makes this distinction possible. The BaseModel class is the foundation of Pydantic. To define a schema, you create a standard Python class and inherit from BaseModel. Once you do that, Pydantic transforms your class into a strict data container. You define the shape of your data using standard Python type hints. You do not need proprietary functions to declare a string or a number. You simply write the attribute name, a colon, and the expected Python type. Consider a user model. Inside the class, you define a single field named ID, and you type it as an integer. You might also add a name field typed as a string. That is the entire definition. Here is the key insight. The actual work happens the moment you instantiate the model. You create an instance by passing your data as keyword arguments, matching the field names you defined. When you do this, Pydantic intercepts the data before the object is fully initialized. It compares the incoming values against your type hints. This is where coercion happens. If you pass the integer 123 into the ID field, Pydantic accepts it immediately. But suppose you are receiving data from a web request or a text file, and you pass the string 123 into that exact same field. Pydantic does not instantly throw an error. It recognizes that the target type is an integer and attempts to convert the string. Because the characters can be safely cast to a number, Pydantic performs the conversion silently. The object is created and the ID field stores a true Python integer, not a string. This behavior proves that Pydantic is essentially a parsing library. It transforms incoming data to fit the strict schema you defined. Of course, this conversion has logical limits. If you instantiate the user model and pass the string not an inch to the ID field, Pydantic attempts the conversion and fails. When coercion is impossible, Pydantic raises a validation error. This error halts execution immediately. One crucial detail about the validation error is that Pydantic evaluates all fields before raising it. If your model has multiple fields with invalid data, the exception will contain the details for all the failures rather than stopping at the very first mistake. The error points out the exact fields that caused the problem, the specific values provided, and the reasons they failed to parse. Once your data successfully passes through instantiation, the resulting object is guaranteed to match your type hints. You access the data exactly like any standard Python object using dot notation. If you assigned the instance to a variable called user, you simply type user.id to retrieve the integer. There are no getter or setter methods required. You are interacting with a clean, strongly typed object. The true value of inheriting from BaseModel is not just that it rejects bad inputs, but that it safely normalizes unpredictable external data into a highly predictable internal state. Thanks for listening. Take care, everyone.